Right. So, welcome back to this session. In fact, it would be a continuation of what we had done last time. Now, last time I had concentrated mostly on random experiment, random variables. And as you recall, the topic is random variable and probability distribution. So, you have come to know what is meant by probability. Now, probability distribution. What is meant by probability distribution? No, nothing to be worried after seeing a new term, distribution. And I am expecting that you have understood the basics of probability. Now say, when we talk about probability of one event, getting a head in the toss of a coin, so that is a probability. But when you talk about probability over a distribution of events, over a spread of events, then it is a probability distribution. And it is always expressed again in terms of a number. So say, you know now what is a random variable. What was the other name I said for random variable? Stochastic variable. CHAS. Anyway, so that is the other name, stochastic variable. Now, with every random variable, say x, you define a probability distribution function fx, right? So, let us take the simplest one, the roll of die. So, what would be the value of x, what would be the value of fx? What are the values of x here in the roll of die? What are the values of x? Quickly. So what is the confusion here? Why are you not coming out with the answer? Even if you feel that it's a wrong answer, please tell. Don't hesitate to tell. I'm telling you time and again. Please don't hesitate to tell and then you shout. Don't tell in a murmuring voice. So what are the values of x if it is roll of a die? 1, 2, 3, 4, 5, 6. इसमें कुछ डाउट है, कुछ कंफ्यूजन है, बताइए तो फिर उसको मैं क्लैरिफाई करता हूँ. है नहीं ना, मैं तो आपको हाथ में पकड़ा के भी दिखा दिया, आपने लूडो कितने बार खेल चुके हैं. तो ये बोलने में इतना डर, why are you getting afraid of saying that the numbers are 1, 2, 3, 4, 5, 6? Say clearly. So you know the values of x. One, 2, 3, 4, 5, 6. What would be the value of fx? Fx is the value of probability. What would be the value of fx? In each case it is bus. So this is the case of roll of a die. Now let me describe that particular event. Tossing of 3 coins and the number of heads. So can you prepare this table? Tossing of 3 coins and number of heads. X, fx. How many values of x are there? 12 values of x. Pardon? 8 values of x. What about you?
Yes, sir,
8 values of x.
Yes, sir.
What?
2, 3, sir. So
What are those values of x? There are 8 outcomes, but what are the values of x? X क्या है देखिए ना? Number of heads in the tossing of 3 coins.
Sir, 1, 2 and 3.
0 नहीं हो सकता है.
Heavy 0, yes.
So how many values of x? 0, 1, 2. There should not be any doubt regarding this. Huh? 0, 1, 2, 3. ठीक है? So how many such boxes should I draw? Time and again I am telling that the random variable is such which can be counted, which can be denoted by a number, and that number is not predictable. Somebody said 8. 8 is the total number of outcomes. That is what I am not asking for, the number of heads. Now what is the probability for 0? X is equal to 0. No head means what?
7 by 8.
No head is 7. Huh?
1 by 8.
No head means tail, tail, tail. Isn't it? So the probability is? What about 1 head? You look back. You look back at your notes. 3 by 8, right? What about 2 heads? Very good. And what about 3 heads? Now see the values of x here in these 2 examples. These are the 2 prolific examples. The values of x here in both the cases are discrete. You know what is meant by discrete? Discontinuous. These are discontinuous values. 1, 2, 3, 4, 5, 6, or 0, 1, 2, 3. So these are discrete random variable. Or for that matter, whatever examples I had cited, these are all discrete random variable. Number of 4-story building in a road, number of misprints in a page of a book chosen randomly. These are all discrete random variable. Can you cite an example of a continuous random variable? Dictionary.
Continuous page number, sir.
Page numbers are continuous.
70.
So in between 1 and 2 there are no numbers. 1.5, 1.4, 1.3. Say during the process of your fundamental growth, when you were born, say you were, how many, say 20 centimeters long. Maybe now you are 150 centimeters long. Now if I calculate your height on any particular day, is it a continuous variable or a random variable? During your stage of growth, at some stage the fundamental growth, you can grow in your breadth, but fundamental growth is the growth in the length. That stops at a certain point of time. So during that period, if I measure your height, is it a continuous variable or a random variable? Discrete variable. It's a random variable, but is it continuous or discrete? Why it is continuous?
Because it will be same for coming.
Say the minimum height was 20 centimeter, the maximum height is 150 centimeter. So during the process of your growth, the value of your height has changed from 20 to 150. Now you might have measured it at say 5 points of time, or say every year on your birthday you had measured, suppose. So suppose if you are 20 years old, then you have measured it 20 times and you have got 20 values between 20 and 150, right? So it may appear those 20 values are discontinuous. Say at some stage it was 20, then 40, 60, whatever. But your height has grown continuously. We may not be able to assess. It is growing. Maybe every day the growth is infinitesimal. You know what is the meaning of infinitesimal? Infinitesimal means infinitely small. That is smaller than the smallest you can conceive about. Infinitesimal means smaller than the smallest It cannot be measured. You may say the smallest you can conceive about is 10 to the power of minus 10. That is point laga ke 10 zeros then 1. I will say 10 to the power of minus 11 is the smallest I can conceive. He will say 10 to the power of minus 12 is the smallest he can conceive. So there is no end to it. So infinitesimal means smaller than the smallest you can conceive about. You had got this idea when you had studied calculus. So your growth might have been infinitesimal, but it is continuous. Okay. Number of runs scored by Sachin Tendulkar in all the one-day matches he has played, is it continuous or discrete?
Discrete.
Discrete because only integral values are there. Non-integral values are not there, so no question of continuity. Snowfall in Lahul Spiti or say Kulu Manali during the month of December. It is
Discrete, sir.
discrete.
Yes, sir.
You might be measuring it again every day at a certain point of time, but the snowfall, the snow grows, isn't it? So it is a, see, you may be measuring at, you cannot measure it continuously, like your height. Have I been able to bring home the example of height? So you are not measuring height every day or at every instant of time. Not even the question of, even if you measure it every day, it would come out to be discontinuous. But the variable is varying continuously. Similarly, the snowfall at a particular place is also varying continually. You may be measuring the height at a particular place of snow at one particular time of the day. Say every day you are measuring it at 10 a.m. So you are getting discontinuous values. But the variable is continuous. Since you are students of science, you would be knowing that the motion of particles or motion of gas molecules, say in a chamber. So it has random velocities. You have read Brownian motion. You have read kinetic theory of gases. Now what about the velocity of a molecule of a gas? Is it a discrete random variable or a continuous random variable? Is it a random variable, velocity of a gas in a gas chamber or in a, say in this room, velocity of air particles? Is it a, if you chase a particular air particle and you keep on measuring its velocity, will it be a, first of all tell me, will it be a random variable? Yes, it is very much a random variable. Is it a discrete random variable or continuous random variable? क्या लगता है आपको, डिस्क्रीट है या कंटिन्यूअस है? Okay, think about it. It is continuous. The velocity changes continually. So whatever be the minimum value, whatever be the maximum value, in that particular range, it changes continually. Again, it is a limitation of our measurement. We cannot chase it all along and keep on measuring the velocity at every instant of time. So it is a limitation of our methods of measurement, but the fact remains that the particular variable changes continually. So this is again a continuous random variable, right? Anyway, so as far as binomial distribution is concerned, we'll be handling only discrete random variables. So these are two cases of discrete random variable. Achha, so now I am assigning a problem. You are tossing one coin repeatedly. Problem को समझ लीजिए पहले ठीक से. You are tossing one coin repeatedly. Now the random variable is number of tails before the first head. इसका टेबल बनाइए. Now how many values x can take? Like in the first example, x could take 6 values. In the second example, x could take 4 values. Here, how many values x can take? Pardon? Pardon? Please tell loudly.
Because we are tossing the coin very much time.
Uh-huh.
So it's not indefinite.
It's not?
Definite.
It's not definite. Have you got the point?
Yeah.
Huh? Fantastic. So, see, you toss the first coin. You never know whether it would be a head or tail. Now, suppose it's a head, the number of tails before the first head is 0. So, head may appear in the first trial. If head appears in the first trial, then the value of x is 0. If head appears in the second trial, the number of tails is. If head appears in the third trial, then it is 2, like that. So then construct the table. And let me keep the other 2 examples intact. I am just writing in short the dice case. Oh, sorry. I am making it 6. Huh? This is the, you write it properly, 1, 2, 3, 4, 5, 6. Huh? And that 3 coins. So there the instances were. Now for the time being, don't concentrate on what I am writing. You try to complete this table. Now one interesting thing have you observed? There are 2 things which emerges from this table. One is that fx is greater than or equal to 0, and sum of fx, this is a summation sign, is equal to. So these 2 conditions have to be valid. So this is again a very what should I say, a very common question. You are given a probability distribution function and you will be asked to check whether it is a valid probability distribution function or not. For it being valid, every element should be greater than or equal to 0, and the sum total of each element should be equal to 1. Right. Now, so this can be up to any number n, isn't it? Huh? So what would be the probability here? That means the probability of getting a head in the first throw. What is the probability?
1 by n.
Why 1 by n? First throw means how many throws?
1 through.
1 throw. So effectively you are working out the probability of getting a head in 1 throw. That is how much?
1 by 2.
Huh? As simple as that. Okay, you write the event space along with that. So if this be the situation, then the event is just head. The probability you know is half. If this has happened, then how do you write the event? If this has happened, then what is the first throw? Huh? So TH, right? So what is the result? What is the probability?
It's 2 by 4.
Why 2 by 4? Tail in first, head in second. What's the probability? What is the probability of tail in first? Forget about the second one. What is the probability of tail in first?
1 by 2.
And what is the probability of head in second?
1 by 2.
So what's the probability of tail in first and head in second?
1 by 4.
1 by 2 into 1 by 2. I'm creating the entire event space here. In the toss of 2 coins, it could have been tail, head, head, tail, head, head, tail, tail. So that way also you get, this is 1 and total number is, so that way also you are getting that it is 1 by 4. But better look at it in this manner, half into half. Okay. Achha, what would have been this situation?
Tail, tail, head.
Fine. Tail, tail, head. What will be the probability?
1 by 8.
Tell it like this, half into half. Now tell me this one, what would be the probability? How many tails? You write it like that. See, here it is 0 tail, 1 head. 1 tail, head in any case will be 1. So the deciding factor is number of tails. Now, as much is the number, that many number of tails. See, here the number is 1, number of tail is 1. Number is 2, number of tails 2. So what would be the number here? Number of
N
tails?
number of tails.
So n tails, let me write like this, n tails, then a head. That is the situation, no? Huh? So what is the probability of n tails? N tails in n throws. 1 tail in 1 throw is how much? 2 tails in 2 throws is how much? 2 tails in 2 throws is how much? 1 by 2 into 1 by 2. 3 tails in 3 throws is how much?
1 by 8.
So this one would be what? N tails in n throws? Half to the power of
N.
n. Half to the power of
N.
n. Got it? You got it? Half to the power of n. And then 1 head. So actually it is half to the power of n plus 1. So now verify this. Quick. Verify this. Is the first one getting satisfied? Fx is greater than equal to 0 for each. So that is clean. Whenever you go to solve a problem, first do the simple parts. Not only in mathematics, in life also. Suppose you are encountering 3-4 problems, try to find out which are the simple ones. So first you get rid of that. Now, first step is very simple. By observing each value of fx, you are finding that each one of them is greater than or equal to 0. Now verify the second one. Summation is equal to 1. Quickly. How do you verify that? Summation is equal to 1. So let me write the summation. It is half plus half square plus half up to how many terms?
Half n plus 1.
Huh?
N plus 1.
How you can say give a wrong answer? You said the total number of outcome would be. You said it first. Total number of outcome would be
Indefinite.
Indefinite means what is the total? How mathematically how do you express indefinite?
Infinite.
So total number of terms is.
Infinite.
This is the nth one, but the matter does not stop here.
Okay.
The matter is not ending here. N can be anything. So this is the nth occasion. But it does not stop at n, isn't it? N can be anything. As you said very rightly at the beginning. So this would be how many terms? 2?
Infinity.
To infinite number of. So can you work out this sum? Have you done infinite? This is a GP series. Common ratio is half. What is the sum of this GP series? A plus AR plus AR square up to infinity. You remember? What is that? GP series. You are telling the general one. You are telling this one. A by 1 minus r to the power of n by 1 minus r. That's what you are saying. If it is a GP series and if r is less than 1, if the modulus of r is less than 1, then this goes to 0. If modulus of r is less than 1, that means r is a proper fraction. What is meant by a proper fraction? Proofs? What is a proper fraction? Is half a proper fraction? Proper improper fraction? A proper fraction is one whose denominator is always greater than numerator. So 7 by 2 is a fraction, but it's not a proper fraction. 8 by 3 is a fraction, but not a proper fraction. But 3 by 8 is a proper fraction. And when you express a proper fraction as 1 by something, then that something is always more than 1. When you express a proper fraction as 1 by something, then that something is always more than 1. So, if something is less than 1, then it's a proper fraction. So, it would be equivalent to 1 by, say, something s, where s is greater than 1. Now, when this is raised to the power of n, 1 to the power of n is what?
1.
But this to the power of n will be a big number. And when n goes to infinity, this will still remain 1. But this will go to infinity. So the whole thing will go to 0. So if r is less than 1, then r to the power of n goes to 0. And this value becomes then a by a into 1 minus r to the power of n. So this is only 1. The numerator is 1 and this is 1 minus r. So this is a by 1 minus r, where a is the first term and r is the common ratio. Now in this series, what is the first term? What is a?
1 by 2.
So this will be equal to a is 1 by 2 and what is r? What is the common ratio?
1 by 2.
So what is this value? Half by
1 आ गया.
आ गया ना 1? मजा आ गया ना? Huh? So you have verified this one also. So these are the two things which have to be satisfied. Huh? That each fx should be greater than equal to 0 and summation of fx should be equal to 1. Now quickly let us do a problem.
So please don't rub this.
Pardon?
So please don't rub this.
Oh, okay. Can I rub this part?
Yeah.
Quickly work out a problem. See, x is a discrete random variable having these values. So it has 8 values. This is 0, this is 2, this is twice 2, this is twice 2, this is twice 2, this is 2, this is twice 2. So this is the probability distribution function. Find out the value of k. find out the value of k. Find out the value of k. First find the value of k. Find the probability of x less than equal to 6. Find the probability of x greater than equal to 6. So now can I erase this part? Have you understood the problem? If you have difficulty in understanding the problem, please tell me. You have been given, now so far I have been asking you to write the distribution function, but now I have given the distribution function. But the distribution function is not given in terms of numbers. Like in every other case you got the numbers, 1 by 6, 1 by 6, 1 by 6, or 1 by 8, 3 by 8, 3 by 8, like that. But here I have given it in terms of a variable k or a constant k. K is a constant which you have to determine. So first you have to determine the constant k. This is a discrete random variable assuming effectively 7 values, because this value is not assuming at all. Or you can say that it is assuming 8 values. The probability of 0 is 0, 1 is k, 2 is 2k, 3 is also 2k. Nothing to identify between the numbers and the multiple of k. 4 is 3k, k square, 2k square, 7k square plus k. So first you determine the value of k, then the probability of x being less than or equal to 6 and the probability of x being greater than 6. First tell me how you do that. Fantastic. So sum of which numbers?
0 plus k plus 2k.
This condition you are not applying now, but this condition has to be valid. So you are applying this condition. So apply it. Very good. So what is the sum? K 0, forget about it. So look here, k plus 2k is 5k, 8k, and here is one more k, so 9k, and this is k square is 7 plus 2 plus 1, 10. So 10k square plus 9k should be equal to, so determine k quickly. What are the values of k? Factorize it. 10k square plus 9k minus, bolo. Have you got this? So what are the possible values of k? So these are the possible values of 10. K is equal to, if the first factor is 0, k is equal to 1 by 10. If the second factor is 0, k is equal to, now are both the values valid? How do you validate the values of k? Second one is because if
it
k
is
is equal to
less.
minus 1, then this probability becomes negative, this becomes negative, this becomes negative, this becomes negative. So this condition is not satisfied. So k cannot be equal to
-1.
So k is equal to
1 by 10.
1 by 10. So if k is equal to 1 by 10, now you can write the values. This is 0.1, this is 0.2, this is also 0.2, this is 0.3, this is 0.01, 2k square would be 0.02, and 7k square would be 0.07 plus k, so this would be 0.17. Okay? Huh? Just don't copy from there, you also work out. 7k square plus k is 0.17. So now find out this one, probability that x is less than equal to 6. Probability that x is less than equal to 6 means x can be what? X can be, it's a discrete random variable assuming values 0, 1, 2, 3, 4, 5, 6, 7. Less than equal to 6 means up to, suppose this is not greater than equal to, greater than 6, up to this. Huh? So you add all the probabilities, what it comes to. 0.1 plus 0.2 is 0.3, 0.5, 0.8. So this would be 0.83, right? Naturally, because this is 0.17, the sum has to be equal to 1, greater than equal to 6. I beg your pardon, less than equal to 6 and greater than 6 are mutually exclusive. Less than equal to 6 and greater than 6, these are mutually exclusive. So their sum will be equal to 1. And that is what is happening. The sum of this much is and this is 0.17. Okay. So you will be able to handle this kind of problem. You have understood what is meant by a random variable. You have understood what is meant by a discrete. What we have done. Let us sum up. You have understood what is meant by a random experiment. You have understood what is meant by a random variable. You have understood what is meant by the probability of a random variable. And then among the random variables there are discrete random variable. So this is a doubtful area, I still feel, isn't it? Continuous random variable. So please think about the 3 examples which I had given. Your height from your birth to the final stage of fundamental growth, not growth in width. Your growth from birth to the final stage of fundamental growth. Snowfall in Kulu Manali during the month of December 2006 and velocity of one air particle in this room. Please think about it. That whether it is a, because we will have to handle continuous random variables also. But as far as binomial distribution is concerned, we handle only discrete random variables. So first of all, quickly tell me what is a binomial. पहले binomial समझेंगे फिर ना binomial distribution समझेंगे. What is a binomial? Quickly. Bi means what? Bi? 2. Very good. So what is a binomial? An expression having 2 terms. That is binomial. Now the simplest binomial is this, where the 2 terms are of 1 degree. This is the simplest binomial. Like this 7k square plus k is also a binomial. But if you have 2 terms, then that's the 2 terms each of 1 degree, that is the simplest binomial. Now what is a plus x whole to the power of n? This is the binomial theorem. Bolo? What is the first term? You don't remember? You don't remember binomial theorem. So tell me that you don't remember binomial theorem. So then rather than writing a plus x whole to the power of n, I am starting from the power 0. Okay, what is a plus x whole to the power of 0? Anything raised to the power of 0 is? Fine. A plus x whole to the power of 1. A plus x whole square. A square plus 2ax plus x square. A plus x whole cube. इतना तक तो बता सकते हैं. A cube plus
Q.
write in descending order of A. A cube plus 3
3.
square x.
3x square.
Now can you construct this triangle? Huh? This triangle can you construct? See 1. I am writing the coefficients only. Huh? 1, 1. And in every stage the number of terms is 1 more than the power. See, if the power is 0, number of terms is 1. If the power is 1, number of terms is
2.
if the power is 2, number of terms is
3.
if the power is 3, number of terms is
4.
so had you observed this symmetry? हाँ, पहले सोचा था ये कभी बाइनोमियल में 1 1 then this is 1 2 1 1 3 3 1. So now you will be able to construct the remaining. First term will be 1.
1.
See, this 2 can be obtained as 1 plus 1 equal to 2. This 3 can be obtained as 1 plus 2 equal to 2 plus 1 equal to. तो यहाँ भी आप करिए 1 plus 3 equal to 3 plus 3 3 plus 1 और लास्ट में तो 1 रहेगा ट्रायंगल बनाने के लिए. अगेन 1 1 plus 4
5.
4 plus 6
10.
6 plus 4
10.
4 plus 1
5.
this
1.
is 1. So what is a plus x whole to the power of 4 then? A plus x whole to the power of 4 would be a to the power of 4 plus 4 plus 6. a एक घट रहा है, x एक बढ़ रहा है. 6 square x square then 4a
X cube. Yes.
what is to the power of 5? Again a to the power of 5 plus 5 plus 10 a cube x square plus 10 a square x cube plus 5a x to the power of 4 plus x to the power of 5. Right? Huh? So okay, so at least we learned how to get the coefficients of x. Now how to generalize it? Please think about it. Please come prepared at least with binomial expansion, because that would be very much essential in the study of binomial distribution. And then your Poisson distribution is very much linked with binomial distribution. I think if you come prepared with that, then you will be able to do more efficiently binomial distribution and Poisson distribution. Okay? So in the next lecture we will be taking up binomial distribution and Poisson distribution.